So in the following triangle BUG, what is the length of side G? So this side over here. If the length of side B is 33 units, so I'm going to write it in here. And then the length of side U is 20 units. So over here, we'll go 20, and that represents this length over here. So again, because we have a right-angled triangle, which is over here, we know that we have to use c squared is equal to a squared plus b squared, where c would refer to the hypotenuse. And so, again, like we learned in our roots and powers unit, in order to remove the root, we have to, or remove the square, I should say, we have to root both sides. So rooting both sides, we get c is equal to the root of a squared plus b squared. In this case, it doesn't matter which one we label as a or b, but we could say that it is 20 squared plus 33 squared. And then if you take the root, that gives us a total of about 1489. And so the square root of 1489 is about 38.59, which in this case would give us option C over here. So for this question, a rectangle field has dimensions of 390 meters, so that would be this side over here, and 140, so that would be this side over here. Eli walks across the rectangular field in a diagonal line. So Eli traverses this path over here to get from this side to this side. Miriam, who kind of likes Eli but is a bit shy, walks around the two sides of the field. So she goes this path instead. And then they meet over here. How much farther did Miriam walk compared to Eli? So what we're going to do is first we're going to figure out how much Eli actually walked, which is going to be this hypotenuse here. So this is how much Eli walked. And so we're going to go, if that's a hypotenuse, remember that that is equal to c squared is equal to a squared plus b squared, which the root of that would give us c is equal to, and the a squared, let's say we're saying that that is 140 squared plus 390 squared. When we square root that fully, we end up getting about 414.367, and that's how long Eli walked. Now to figure out how much Miriam walked, we're going to add these two. So this is for Eli, and then for Miriam, it's going to be 390 plus 140 meters. So again, because she walks here and here, and so that's going to give us a total distance of about 530 meters. So then they want to know how much farther did she walk than Eli? Well, we could simply take the difference between the total distance that Miriam walks, which is 530 meters, subtracted by the distance that Eli walks, which is 1,414.367 meters. And the difference between the two is roughly, it's about 160 meters. So that would give us the answer A, which is closest to what we got over here. So for this one, which is more of a roots question, Daniel was calculating the square root of 114.5. In order to make an estimate, he looked at the two closest perfect squares on either side of 114.5. Now what they mean by that is the perfect square that is lower than 114.5 would be, well, it'd be 100, right? If I take the square root of 100, that equals 10. And then the one that is the next perfect square that is higher would be 121, which the square root of that would be 11. And so you know that this value is between 100 and 121, which means that the value is in between 10 and 11. And so the sum of the square roots, if we go 10 plus 11, they want to know what the sum of the square roots is, then that would equal 21. And so while this would be, perhaps one square root, the sum of the square roots would actually be 21 here. So C would be our best answer. Now for this next one, it's a little bit trickier. It says Sue plotted several values on a number line. The values of W, X, Y, and Z respectively could be. Now, on the number line itself, which is separated into 0, 1, and 2, the values that are placed here representing W, X, Y, and Z are actually roots of those values. So what you have to go through here is take the root of each of these proposed sequences and see where that would end up. So let's say if I pick this one here, looks like it's in between 0 and 1. And so if I want to figure out what the root of that, which would give me about in between 0 and 1, I could either go 0.3, let's say if I'm starting at D and making my way up here, 0.3 and the root of that, and that gives me about 0.55. And then if I look at the root of 0.9, I get about 0.95, and I see that these correspond, so that's one way of doing it. What you also could do, the thing is you would have to test every single line here. What you could do is you could square these numbers like a rough estimate. So this one looks like, let's say if it's about 0.5 and I square that, I would get also the original value that is outside the root. And that would be roughly about 0.25, which the closest value would be 3 over here. If I take this one, which I would say 0.9, so if I squared 0.95, that actually would be closer to 0.90. And then let's say for this one here, it looks like it's about, let's say it's about 1.2. And I think that's a fair estimate here. I get a value of about 1.44. And then that corresponds with this value. And then if I look at Z, finally, it looks like it's at about roughly 1.9 or so. Let's say it's about 1.92. So if I square 1.92, then I get about 3.7, which would correspond to this value here. So the option that matches each one of these would be option D. And again, there's two ways you could have approached it. You can take the estimates of these and do the inverse operation, which the inverse operation of a square, remember, is an exponent. So root x would be an exponent. Or I could take each of these, go line by line, take the square roots and see which one would be closest to these values.